Hello. So what I'm going to do is just to explain the power rule and then to do some examples so that you could look at some examples and then understand some of the different ways in which the power rule can be applied. First of all, it's important to understand what are the steps to apply the power rule. And I call that the formula. And these steps are you want to multiply the exponent by the coefficient at the front. So when you have a term, take the exponent multiplied by the coefficient at the front or the number at the front. And then you're going to subtract that exponent or take that exponent and subtract 1 from it. And then that's pretty much it. So here are some examples. Here's example 1. You see we actually have several different terms. So when you have a polynomial like this and you have several different terms, then all you have to do is apply the power rule to each individual one. So let's go ahead and apply the power rule. We multiply the exponent by the coefficient at the front. So this is the number at the front. We're going to multiply the exponent. 2 times -2 will give us -4. So I write down -4. And then we take that exponent and we subtract 1 from it. So that's going to be a t to the first power because 2 minus 1 is 1. And you don't actually have to write that 1 there. You can leave it invisible if you want to. We go to the next one. Now keep in mind that just to be careful of your signs here, okay? So here we have 3t, which has an invisible 1 as an exponent here. And so essentially what you're going to do here is take the 1, multiply it by the 3. So that would give us a +3. And then this exponent where there's an invisible 1 here, subtract another one, which will give you an exponent of 0. And anything to the exponent of 0 is just going to be 1. So that just leaves 3 times 1, which is 3. So to make it a little bit easier, anytime you see a variable to the first power and a number in front of it or coefficient in front of it, it's just going to be that number or coefficient. So if I see a 3t, the derivative is 3. If I see a 5z, the derivative is going to be 5, and so forth. Now also remember that anytime you have a constant or just a number and no variable, then that derivative is going to be 0, okay? So here we have a 0. So this would be our derivative. Now, oftentimes your book, erase this very quickly. Oftentimes your book will either say y equals, okay? And if your book does say y equals, then the way that you would symbolize the derivative is you would say dy, and in this case, dt. So at the bottom goes whatever variable is in that equation, okay? All right, let's move to this example. Now, sometimes you will have an example in which it's hard to really access the exponent. So your exponent might be at the bottom of the denominator, or you might have a radical, which we'll face a little bit later. But what we want to do first here is we want to go ahead and move this exponent to the top or get rid of the fraction, all right? It's very difficult to do the power rule when you have the exponent at the bottom of a fraction. So remember, we have to convert this. So we're going to convert this. And remember how you convert, okay? You're going to flip that exponent, all right, and change the sign of it, all right? So this x to the 8th will flip to the top and become 1 times, so 1 times x to the 8th, but then it's going to become opposite of what it was before. So before it was a positive, now this exponent becomes a negative whenever you flip it, okay? So essentially, we have x to the -8th. Make sure you can see that. So how do we take the power rule here? Same thing we did before. Take the exponent, multiply it by the coefficient in front. Here, if there's nothing in front, you understand that there's an invisible 1 as a coefficient. So -8 times 1 will give us -8. And then you subtract 1 from this exponent here. -8 minus 1 is -9. So we have -8x to the -9th. Now, the reason why we're not finished yet here is they typically don't like you to leave exponents that are negative, all right? So we're going to do what we did before when we simplify to get rid of a negative exponent, same way we did to move this up to the top, is you just flip it and then you change the sign, okay? Now, when you flip it, you're only flipping the base and its exponent, all right? The -8 stays where it is. So the -8 stays at the top. we flip the x to the negative ninth to the bottom, and it just becomes x to the ninth because we take the opposite of the sign, right? And this will be our final answer. Now, keep in mind, the reason I said that this was at the top, because you can always do a division bar and put a 1 at the bottom if you want to turn something into a fraction. So that's why I knew that, hey, this negative 8 stayed at the top. This base and this exponent, we flip to the bottom, okay, and then change the sign right here to give us negative 8 over x to the ninth. And that will be our derivative. Now, sometimes what will happen is your book will put in a function notation. They'll say f of x equals. And if they do that, then the symbol you want to use for your derivative is called f prime of x, which is this little accent mark, okay? That means your derivative. And the reason why I'm showing you that is because when you read in your book, you want to understand kind of what they're showing you. All right, here's another example. We have 4 over 3x squared, okay? So again, what we're going to do is we're going to rewrite it first because it's hard to take the power rule when you have your base and exponent in the bottom of a fraction. So this is going to convert, okay? Now remember, the only thing that flips is the base and its exponent. So this 3 stays the same, the 4 stays the same. So we still have 4 over 3 here, but the x squared flips to the top, and then I take the opposite of its sign. It was positive, so that means it's negative right here. Now, I can rewrite this so that I have the fraction at the front, the 4/3, and then x to negative 2. So these are the same thing, all right? So I can write this at the top as well, or I can write it at the side. And the reason why I wrote it at the side right here is because it highlights what your coefficient is. My coefficient is 4/3. So to do the power rule, we're going to take the negative 2 multiplied by the 4/3. Now, when you multiply a fraction by a number, a whole number, you just multiply it on the top. So multiply the what's called the numerator, okay? So we're going to say negative 2 times 4. That gives us negative 8, and we still have negative 8/3. So 4/3 of negative 2 is negative 8/3. Now, if you have a problem with this, don't get bogged down. I've showed you how to do it in your calculator. You should know how to do it in your calculator, okay? Now, to move on from that, we have to subtract 1 here. So that leaves us x to the negative 3rd, okay? But remember, again, we don't like to have negative exponents. So right now, this is viewed, anything at the side is the same thing as something being at the top. So this is negative 8x to the negative 3rd over 3. To get rid of this negative exponent, we have to flip it. Remember, only flip the base and the exponent. Everything else stays the same. So we finally get where the negative 8 and the 3 stays the same. This base and exponent flips to the bottom and changes sign. So we get x to the 3rd. So our final answer will be negative 8 over 3x to the 3rd. Okay, here's another example. We have x to the 4/5 minus x to the 2/3. Again, since we have two different terms, we can do the power rule on them separately. So the power rule on x to the 4/5 is you take the exponent, multiply it by the coefficient in front, which is an invisible 1 here. So we will have 4/5, okay? And then we'll have x, I'll just write at the top here. Now we have to subtract 1 from here, okay? So remember, you can do this by your calculator if you want to. Take 4/5 and subtract 1, or understand that 1 can also be written as 5/5, okay? So if you take 4/5 and you subtract 5/5, then you will get a negative 1/5. Okay, because when you're subtracting fractions with the same denominator, see if I was subtracting fractions with the same denominator here, then they both have 5 as the denominator, then I just subtract the top. 4 minus 5 is negative 1. Keep the denominator, and I get negative 1 over 5. All right, what about this one? So we have, again, multiply the power by whatever coefficient is in front, which would be an invisible 1. But remember, this also has a sign of negative. So we have 2/3 times -1, which will give us -2/3. And then subtract 1 from here, which is like saying subtract 3/3, which will give us -1/3. So x to -1/3. So now again, we just want to rewrite. We're going to flip this to the bottom and change the sign. So we're going to have 4 over 5x to the 1/5. And then same thing right here. We're going to flip this to the bottom so we can get rid of the negative, and it will be 2 over x to the 1/3. Remember, if this flips to the bottom, changes sign. Okay, so that would be the derivative in this case. Okay, just a few more examples. We'll leave example 6 alone. I think that'll be enough examples so far. Now we have a 2 over the square root of x. So whenever you have a square root, you also have to rewrite that. A square root is a fractional exponent, and the fraction is 1/2. So we convert this to 2 over x to the 1/2. Now, again, it's very difficult to do power rule when your exponent is at the bottom or in the denominator. So we're going to flip it. So we rewrite that as 2x. When we flip it, the sign of the exponent changes. Okay, so that's x to the -1/2. So now we're going to take this and do the power rule. -1/2 times 2 is what? Well, we do, whenever you're multiplying a fraction times another fraction or another number, you just multiply straight across. Okay, and essentially we're saying 2 over 1 times -1/2. Multiply straight across. That will give us -2 times 1 is 2, 1 times 2 is 2, -2 over 2, which is the same thing as -1. So when we multiply -1/2 times 2, you can do that on a calculator as well to make it quick. Then we get -1. So we have -1. And then we're going to have to subtract 1 from the -1/2. So -1/2 minus 1, that's actually going to give us -1.5. Or -3/2. Okay. And the way I get -3/2 is because I'm subtracting 1 is the same thing as 2 over 2. So you can always represent 1 as a number over the same number. Okay. And if you're trying to subtract 1 from a fraction, you're usually going to pick the number to be whatever your denominator or bottom number is. So I subtract 2 over 2. 1 minus 2 is -1 minus 2 is -3. And then you keep the denominator of 2. So that's how we get that. Now, again, we don't like to have an exponent with that's negative. So I'm going to flip that to the bottom. Now I'm flipping again the base and this exponent. Everything else stays where it is. So in the end, we're just going to be getting 1 over x to the 3/2. Okay. And then that would be the answer. Now, I hope this has helped you with the power rule. The power rule is particularly important because you have to know the power rule to do the other rules, to do product rule, quotient rule, and also chain rule. So make sure you practice this. Make sure you're extremely comfortable with it. Thank you.